At Baryon, we are solving elephant-in-the-room type problems facing humanity. The world needs refrigerant-free and much more energy-efficient cooling systems. We cannot reach net zero carbon emissions by 2050 without addressing cooling. Cooling accounts for around 10% of all energy consumption today. Building cooling is a $6 to $7 trillion market through 2050, adding over 4 billion installed air conditioning units globally over the same period. Demand is driven primarily by new installations in the developing world, in particular those that will be hit hardest by climate change. According to the International Energy Agency, building cooling accounts for 37% of all energy demand growth through 2050, the single largest category of growth. How Baryon technology works. First, one must understand the different ways energy can be extracted by a liquid. In typical situations, there are two ways in which energy can be extracted. First one is realized through the temperature change, and second is realized through the phase change. Heat which is extracted through temperature change is named as sensible heat, and that which is extracted through the phase change is called the latent heat. Almost all chemical compounds can occur in three basic phases: solid, liquid, and gaseous. Let's use water as an example. We need to add some energy to increase water temperature, and inversely, when water is cooling down, it emits energy to its surrounding. The same situation occurs when water changes its phase from liquid to gaseous and then back to liquid. The main difference is the amount of energy which is extracted through each of these processes. If we compare the way energy can be extracted from two identical glasses of water, 1 litre each, by changing the temperature by 50 degrees, or by fully evaporating the same amount of water, the difference is that we can get over 10 times more energy extracted from the latent heat transfer than from the sensible heat transfer. The huge amount of energy extracted through evaporation process leads to its usage in cooling. In fact, this method was chosen by nature itself as the most effective cooling mechanism. This is why we sweat. The water in sweat evaporates from our skin to the surrounding air, which extracts heat energy from and cools our bodies and allows us to maintain constant body temperature, even in hot environments. The same process can be used for the purpose of cooling the air. Let us think about two streams of air flowing in separate channels. In one of them, there is a layer of water. To evaporate, water needs to absorb some amount of heat. This heat is transferred directly from the air which surrounds the water, and indirectly through the wall of the channel from the other stream of air. As a result, the temperature of both air streams decreases. It is exactly the same mechanism that our body uses to cool itself. Instead of cooling our body by evaporating the water into the air, we are cooling one airflow by evaporating water into the other airflow. The major problem with effective utilization of phase change process is the humidity of the outdoor air. When the air is humid, the water does not evaporate effectively because the outdoor air is saturated. This was a serious limitation until now. Baryon's revolutionary ESCCC process overcomes these barriers. The evaporation, separation, condensation closed cycle technology, or ESCCC, is realized by unit made of two elements: two-phase cooler, or TPC, and proprietary AI-controlled membrane dehumidifier. The system allows to effectively cool the air with water evaporation in a humid climate due to unique flow arrangement. The system takes the air from the conditioned space, which is cold and dry in the summer season, and delivers it to the channels of the two-phase cooler, which are wetted with water. When cold and dry air contacts with water, the water starts to evaporate very effectively, which allows to realize the first stage of the process. The hot and humid air is delivered to the other channels of the cooler, where it contacts with cold plate, due to the water effectively evaporating on the other side. When hot and humid air contacts with cold surface, it gets cooled and dehumidified. Water condenses on a surface, just like it condenses on a glass of water during a summer day. This allows to realise the second stage of the process, condensation. After passing the two-phase cooler, outdoor air gets cold and dehumidified. However, in order to close the cycle, in expression to achieve the conditions which will allow to compensate the cooling loads inside the room and reach parameters which allow for effective water evaporation in the first stage, the air needs to be additionally dehumidified. For the purpose of this process, an AI-controlled vacuum dehumidifier is implemented. It uses a dedicated membrane, which allows for only water particles to pass through. The vacuum pump generates subpressure on one side of the membrane, which removes the water vapour from the air, allowing to realise the third stage of the process, separation. This allows to close the cycle. The air reaches parameters which allow to compensate the cooling loads inside the room and achieve conditions which are needed to start the effective water evaporation process. The cycle is closed on the water side too. The water obtained from condensation and separation process is returned for the purpose of evaporation. Due to the fact that the mechanism of the process is passive, the only elements which consume the energy are fans, which pass the air through the system, and a vacuum pump for small additional dehumidification. It consumes significantly less energy than any traditional air conditioning systems. The unit consumes from 40 up to 95% less energy than most efficient air conditioning systems, depending on ambient air conditions. Baryon. We are solving the world's cooling problems with sustainable, green, and super efficient solutions.